Okay, so we are going to continue factoring when a equals 1. This is day 2. Let's just get to it. So we're going to look at a couple special cases, and not even really special cases, but a few different things that you might see as you're practicing. We're just going to jump into more examples so you can actually just continue on to the last lesson's notes. So example 4 says factor x squared minus 10x plus 12. Okay, so our a is 1, our b is negative 10, our c is 12. And when we do our little factor puzzle, we know that we need to add up to negative 10 and multiply to 12. So we want to find factors of 12 that are going to add to negative 10. So it would be like negative 12, negative 1, right? Because I need a negative 10. Negative 6, negative 2, negative 4, negative 3. None of these add up to 10. If you cannot find factors that add up to your that add up to your b and multiply to your c, then what you have is a prime polynomial. And so what you would say is either this is a prime polynomial, can't be factored, you could just rewrite the polynomial down, okay? But please be aware that it is a possibility that you will not be able to factor that polynomial the way that it's presented as of right now. Eventually, there will be a process that we'll go through to kind of force the situation. But for now, you can just say it's a prime polynomial and be done. Right? Now, before we look at the next part, there is a way to check and see if it can be factored, because like this last situation, if I needed to find factors of a number that had a ton of factors, you could be sitting there making a list forever. Okay, the guess and check can kind of create some problems. Okay, so there's something called the discriminant. Okay, and discriminant is a word that you will hear often in the next unit and in high school. Okay, so we're going to make a little note here that says to determine if the polynomial is prime, check the discriminant. All right. Now, the discriminant is an expression, b squared minus 4 times a times c. Now, At some point, we'll kind of see where this all comes from. But what's going to happen is if you replace the A, the B, and the C in the positions in this expression, you'll be given a number that will allow you to decide if the polynomial is prime. Okay, so let's do that with our last set of information. Okay, our A was 1, our B was -10, and our C was 12. Okay, so in the last case, the A was 1, the B was -10, and the C was 12. So B squared would be -10 squared. I put it in parentheses because the B gets squared, and the B is -10, right? Minus 4 times the A times the C. Now, -10 squared is 100. 4 times 1 is 4. 4 times 12 is 48. 100 minus 48 is 52. Now, if the discriminant is a perfect square, the polynomial can be factored. In this case, 52 is not a perfect square. Now, if you need a refresher of what a perfect square is, that is a perfect square is a number that has two factors that are the same. So 6 times 6 equals 36. 36 is a perfect square. 49 is a perfect square. 7 times 7. 100 is a perfect square. 10 times 10. Okay, so because 52 is not a perfect square, we would not be able to factor that polynomial. Okay. All right. Let's look at another situation that you're going to see. Now, in the last lesson, we talked about the first thing you want to look for is to see if there is a GCF that you can factor out of your trinomial or polynomial. And that's what's going to happen here. So we want to factor 2n squared plus 6n minus 108. So the first thing we're going to do is factor out the GCF. And if you look, if I identify my A is 2, my B is 6, and my C is -108. Each of these numbers is even, right? So I can factor out a 2. GCF is 2. Now, I will tell you, for right now, we've been factoring trinomials where the A is 1. So the fact that the A is not a 1 is a clue that we've got to factor something out. To help you figure out what needs to get factored out, remember, that has to become a 1. The only way to make 2 become a 1 is to divide by 2, which means a 2 is going to get factored out of the first term. So you can bet that you're going to factor 2 out of the other terms, right? So I factor out my 2, and I'm left with, I'm going to divide a 2 out of each term. So I'm left with n squared plus 3n minus 54. Now that 2 is not going to disappear. The 2 is going to stay on the outside of everything. Okay, so what we're going to do now is now I'm going to re-identify my A, B, and C. Okay. Now my A inside is a 1, my B is a 3, and my C is negative 54. And I've got to create my puzzle. Remembering that I want my B up top and A times C on the bottom, right? 1 times negative 54. And it's going to multiply to make the negative 54. And my two numbers are going to add to become 3. We create our little area model over here. I know that my first term will be in the first box. My last term will be in the last box. I know I'll have an n and an n, right? And these other two numbers here, so these two numbers are going to go in these two spots with an n as the variable. They're also going to go in these two spots, right? Okay, so let's come up with our factors. I need the factors of negative 54, and the sum is going to equal 3, right? So I need a positive and a negative because we have negative 54, and I need to add up to 3, so I've got to have more positives. So the positive factor has to be further away from 0 than the negative, right? Also, because the sum is 3 and they're going to be different signs, I also know my two numbers should be, like the absolute values should be close together, right? So what I mean by that is negative 1, positive 54 makes no sense because those numbers would be so far apart if I thought about the absolute value. Because remember, if my signs are different, I actually subtract my numbers, right? So you can sit and list every single factor and not have any strategy to it, but it's going to take you a lot of time to find your magic factors. So if you use a little strategy, you can save a lot of time. So I know that I need two numbers that are, the digits are close to each other, right? So with negative 54, maybe negative, now 9 and 6 together make 54 when we multiply. So now negative 9, positive 6 doesn't work because I have more negatives. I need more positives so that I get a positive 3. 9 and 6 are close. They are 3 apart, right? So this tells me that those will be my magic factors, right? So I have a 9 and a negative 6. Let me write them in green. Which means I'll have a 9 and a negative 6. Which means I'll have 9n here and negative 6n there, right? But ultimately, these are the two binomials that I will have in my final answer. However, don't forget this little 2 that we factored out from the beginning. That's where people are going to make mistakes. They're going to forget about that 2. So we get 2 times the quantity n plus 9 times the quantity n minus 6. All right, let's do another example. Just going to do a little bit of practice together. 3x squared plus 15x plus 6. Okay, so first step, my a is not 1. I want to try to make it a 1. So that means I'm going to factor out a 3. And if you notice, both of these, my b and my c, also have a factor of 3. So we should be good. So I'm going to get a 3 times x squared plus 5x plus 2. Now remember, if you ever get confused, you can always redistribute and just double check that you get the same thing that you started with, right? Also double check that there are no more common factors, and we're good. All right, so let's make our little puzzle. Identify our a is 1, our b is 5, our c is 2. Put my b up top, and remember that my two numbers are going to add to 5. And they've got to multiply to 2. Okay, now hopefully you've started thinking, well, hold on. If they multiply to 2, the only options are 2 and 1, and those don't add to 5. So your first thought, hopefully, is that this trinomial inside is not factorable. And if we look at the discriminant that we talked about before example 5, b squared minus 4ac. Okay, let's check that out. 5 squared minus 4 times 1 times 2 is 25 minus 8, which is 17. It is not perfect, which means that this expression cannot be factored any further as of right now. Now, that doesn't mean you couldn't do anything, because if you notice, we did factor out a 3. All that means is this is our final answer right here. Okay? And let's do one last one. Seven, yep. Okay. X squared minus x minus 5x plus 6. So x squared minus 5x plus 6. Okay, nothing to factor out from the start, so let's identify our a, the b, and the c. Let's get our puzzle here. They add up to the b, and my two numbers are going to multiply to 6, right? And if we do the area model, again, remember, probably going to feel like the area model is pointless right now, a little bit of extra work. However, some people will be able to visualize this better with the area model. And like I said, moving down the line, there will be times where having practice with the area model will actually save you a lot of time. So we're going to continue working with it, right? We know that our first box is our first term. The last box is our last term. And these middle boxes here are the two terms that are going to add up to negative 5x, right? So I also know that this is an x and an x. I know that these two numbers are going to multiply to make 6, add to make -5, right? So let's find our factors. Factors of 6 that add to -5. So because they're adding to a negative, I know that I need 2 negatives. The reason I know I need 2 negatives is because the factor is going to be, when I multiply them, I get a positive. So to be able to multiply two numbers and get a positive, but have them add to negative, I need them both to be negative. And it's going to be -3 and -2. Now again, if you couldn't come up with that in your head, that's okay. You would just go through and you would list the factors. There's nothing wrong with listing the factors. We find that -3, -2 are the winning factors. So that means I'm going to have my -3, my -2. When I look at this, I've got my first term here, my last term here, and -2x plus -3x does equal -5x. So I know my information is correct on the outside of my area model. I know that -3 and -2 are my winning factors, which means then that my binomial is going to be x minus 3 times the quantity x minus 2. And that's it.